So first of all, what is Terraform? Terraform allows you to automate and manage your infrastructure and your platform and services that run on that infrastructure. It's open source and it uses declarative language, meaning you don't have to define every step of how this automation and management is done. You just declare what you want, the final result or end result, and Terraform will figure out how to execute it, versus imperative style where you specify how to execute each step. So as I said, Terraform is a tool for infrastructure provisioning. So what does it mean exactly? Let's say you just started a project where you create some application and you want to set up an infrastructure from scratch where this application will run. How does your infrastructure look like? Let's say you want to spin up several servers where you will deploy your 5 microservice applications that make up your application as Docker containers, and also you're gonna deploy a database container. You decide to use AWS platform to build your whole infrastructure on. So first step will be to go to AWS and prepare the setup so the applications can be deployed there. This means you create your private network space, you create and deploy EC2 server instances, you install Docker on each one of those, plus any other tools that you might need for your application. You set up security on your servers, like firewalls, you set up network, etc. Once the infrastructure is prepared, you can now deploy your Docker applications or Docker containers on that prepared infrastructure. So as you see, these are two different tasks or two separate steps of creating the whole setup. One is provisioning the infrastructure, preparing everything so the application can be deployed. The second one is actually deploying the applications on it. So you might even have two separate teams or two individuals who do these two separate tasks. So possible scenario, a DevOps team member configures the infrastructure and a developer then deploys the applications on the prepared infrastructure. So where does Terraform come into this whole thing? Terraform is used for the first part where you provision the infrastructure to prepare it for the application deployment. Creating the VPC, spinning up the servers, creating the security, the AWS user with its permissions, maybe installing Docker specific version on servers, etc. And obviously all of this needs to be done in a correct order because one task maybe depends on the other. Now here I must mention something that a lot of people ask when it comes to Terraform, and that is, what is the difference between Ansible and Terraform? Because they seem to be doing the same thing, especially if you read the official definitions or official documentation, they sound like the same tools. So the question is pretty logical. What is the difference between them and which one should I use for my project? So let's see the similarities and differences between these two, using our example setup. First of all, Terraform and Ansible are both infrastructure as a code, meaning they're both used to automate provisioning, configuring, and managing the infrastructure. However, Terraform is mainly infrastructure provisioning tool. That's where its main power lies. But it also has possibilities to deploy applications and other tools on that infrastructure. Ansible, on the other hand, is mainly a configuration tool. So once the infrastructure is provisioned and it's there, Ansible can now be used to configure it and deploy applications, install and update software on that infrastructure, etc. So as you see, there are overlaps of what each tool does, and this creates the confusion. Other differences to consider in terms of those overlaps are Ansible is more mature and Terraform is relatively new, and because of that, it's also changing dynamically. And Terraform is much more advanced in orchestration. So to summarize the difference, Terraform is a better tool for provisioning infrastructure, and Ansible is a better tool for configuring that infrastructure, deploying, installing applications and services on them. So it's a common practice where DevOps engineers use the combination of these tools to cover the whole setup end to end, using both for their own strength, instead of just using one tool. So now let's go back to our use case where we created the infrastructure using Terraform and on AWS, provisioned successfully for your project, and you deployed the application on it. Now you decide that you want to add 5 more servers to the existing infrastructure to deploy more microservices because your team developed some more features and they need to be deployed. And you also want to add some security configuration or maybe remove some stuff that you configured at the beginning. So now we are in the phase of managing the existing infrastructure, adding some stuff, reconfiguring, removing some stuff, etc. And using Terraform, you can make such adjustments to your infrastructure pretty easily. And this task of managing the infrastructure is just as important because once you've created the initial infrastructure for your project, you will be continually adjusting and changing it. And because of that, you also need some automation tool that will do most of the heavy lifting for you so that you don't have to manually configure and do some stuff. So once you are set up with Terraform to create and change or maintain your infrastructure, another useful thing or a common use case could be replicating that infrastructure. Let's say after you have tested this setup and everything works fine, you decide now you want to release your application in production environment. So you want to create a production environment that replicates this exact setup and keep the first as a development environment where you can test new features, new microservices, and updates before you launch it into production. Again, you can use Terraform here to automate that process. So you can easily spin up an identical infrastructure and set up using the same Terraform code that you use for the first setup, the development environment setup. And you can do the same to spin up an identical staging server as well. So that makes these tasks also very easy. So how does Terraform do all this? How does Terraform actually connect to these infrastructure provider platforms and use all these technologies to provision stuff? So for example, how does Terraform connect to AWS to create virtual space, start EC2 instances, configure networking, etc.? In order to do the job, Terraform has 2 main components that make up its architecture. The first one is Terraform's core. And the core uses 2 input sources in order to do its job. So it takes Terraform configuration that you as a user write and where you define what needs to be created or provisioned. And the second one is Terraform state, where Terraform keeps the up-to-date state of how the current setup of the infrastructure looks like. So what core then does is it takes this input and it figures out the plan of what needs to be done. So it compares the state, what is the current state, what is the configuration that you desire, the end result, as I mentioned at the beginning, and compares that. And when it sees there is a difference, or you want something else than what the current state is, it figures out what needs to be done to get to that desired state in the configuration file. So what needs to be created, what needs to be updated, deleted, in which order on that infrastructure setup. And the second component, or the second part of the architecture, are providers for specific technologies. This could be cloud providers like AWS, Azure, or other infrastructure as a service platforms. So for the infrastructure level tasks. But Terraform, as I mentioned, has also providers for more high level components like Kubernetes or other platform as a service tools, even some software as a service tool. So it gives you possibility to create stuff on different levels, like create a AWS infrastructure, then deploy or create Kubernetes on top of it, and then create services inside that or components inside that Kubernetes cluster. So it gives you all these possibilities. And it does that through those providers. Terraform has over 100 providers for these different technologies. And each provider then gives Terraform user access to its resources. So through AWS Provider, for example, you have access to hundreds of AWS resources like EC2 instances, the AWS users, etc. With Kubernetes Provider, you get access to Kubernetes resources like services and deployments and namespaces, etc. So this is how this works. And this way, Terraform tries to help you provision and cover the complete application setup, from infrastructure all the way to the application. And this is sure convenient, but as I mentioned in the comparison between Terraform and Ansible, Terraform's strength is actually in the infrastructure provisioning, and for the other stuff, you can use Ansible or similar tools. So once the core creates an execution plan based on the input from config file and state, it then uses providers for specific technologies to execute the plan, to connect to those platforms and to actually carry out those execution steps. So now, to also have an idea of how Terraform configuration file looks like, this is an example where you see AWS provider is configured, and through that provider, you now have to AWS resource like VPC. You can create that with some attributes. The same way you have the Kubernetes provider here configured, and through that now you can create a Kubernetes namespace resource where you pass some attributes. And the syntax is very intuitive, I would say. Basically, you define what you want. So you want a resource of a certain technology or a certain provider created, and then you define its attributes, and that's what Terraform will create or do for you. Now, one thing I mentioned at the beginning, and I want to go into detail, is the declarative approach that Terraform's configuration files are written in. And this is important to understand. So what does declarative mean exactly? When you create a Terraform file, instead of defining what steps to be executed to create the VPC, or to spin up 5 EC2 instances, or create the network configuration, you define the end state you desire. So you say, I want 5 servers with network configuration like this, and I want one AWS user that has these permissions to access all the servers. Terraform, go do that for me. So instead of defining exactly what to do, which is an imperative approach, you define what the end result should be, a declarative approach. Now, for the initial setup, this may not make much difference. So when you see the configuration of imperative and declarative approach, it might actually look pretty similar. But consider when you're updating your infrastructure, like removing a server or adding another server or making other adjustments. With imperative approach, you would say in a configuration file, remove 2 servers, add a firewall configuration, add some permissions to the AWS user, etc. So you give instructions of what to do. With declarative approach, like in Terraform example, you would say, my new desired state is now 7 servers, this firewall configuration, and user with this set of permissions. Do whatever needs to be done to get from the current state to the new desired state. So now you don't have to actually calculate and decide how many servers needs to be added. You just say, I want 7 servers at the end. That's what I want. Or you don't need to calculate and figure out how many permissions or which permissions you should add. You just say, I want this set of permissions to come out at the end. So with the declarative approach, you just adjust the old configuration file and re-execute it instead of adding the new set of instructions. This is obviously very comfortable because your configuration file stays clean and small, but also you always know what the current setup is just by looking at the configuration file, because that's always the end result. Whereas in the first approach, an imperative, you have to somehow add this up and figure out the delta between all the changes applied by multiple instructions. So you've created a Terraform file, configuration file, that defines your desired infrastructure setup on AWS. Now, how do you make Terraform take action? Terraform has commands you can execute to go through different stages, which is pretty clear and straightforward. The first command is refresh. With this command, Terraform will query the infrastructure provider, in our case AWS, to get the up-to-date state. So Terraform will now know what is the current state of the infrastructure. The next command is plan. Remember I said the core is responsible for taking current state and your configuration file as input and decide based on the difference what needs to be done. That's the plan. So what Terraform needs to do in order to achieve that desired state that you defined in the Terraform configuration file. If it's an initial setup, it figures out all the steps to create the desired setup. If it's an update, it compares the existing setup with a new desired state and figures out what changes and adjustments need to be made in which order to create the new desired state. For example, add a new server, add a new permission, etc. Now this is just a plan. This is where the core kind of constructs the plan logically of what needs to be done. The next command is the command where the actual execution happens. And that's the apply command. So with apply, you can execute the plan. So plan command is like a preview of what's gonna happen. If you execute apply, obviously Terraform in the background will do the refresh, get the up-to-date state, then create the plan and then apply it. Which means if you want to execute a configuration file, you can just execute the apply command and it will do all of this. And another command is destroy, which obviously destroys the whole setup, removing elements one by one in the right order and cleaning up all the resources that were created. Basically reverting everything that has been created. And this could be used if, let's say, you create an environment for an important demo day and you didn't want to interfere with the existing environments. Once the demo is over, you can destroy the whole setup. Destroy, like apply, will also check what's currently running and then create a plan of what needs to be removed in which order. So some of the key takeaways for Terraform are, first of all, Terraform is a tool for creating and configuring infrastructure like virtual servers and so on, and then managing that infrastructure, and not for installing applications on these provisioned servers. Second, Terraform is a universal infrastructure as code tool. So even if every cloud provider has their own infrastructure as code tools, if you have a multi-cloud infrastructure or a hybrid infrastructure, like using your company's on-premise servers and cloud servers, you can use just one tool for all of these environments instead of having teams for each environment, like one team managing the company's own data center infrastructure, one team for AWS infrastructure, and one for Google Cloud, and so on. And finally, because it integrates with many different technologies and platforms like AWS, Kubernetes, Jenkins, VMware, and so on, you have one tool that you can use to talk to all these different technologies and their APIs. So you don't have to learn the API of each tool to talk to them. So Terraform abstracts that layer for you. So now that you understand what Terraform is and all of its benefits, let's actually get started using Terraform in practice.